All right, so you did one on blowing past 2C, kind of relates to what we're talking about. Or how we can't avoid 2 degrees Celsius.
I
Blazing.
don't think it can be avoided at all at this point, just from the
Yeah.
thermal inertia and just from the continuing warming of the permafrost. And now we're seeing acceleration of the methane leaking out of the ocean. So
Yeah, that's what you
there's
mentioned last
another
time.
wild card to toss in there.
So just how much energy have I remember you saying how much energy the oceans have absorbed so far, and like what that means for future, and how it's gonna outgas eventually. It's just
Well, there's a
doomsday.
couple of there's a couple of things at play here. Okay, yes, the oceans have absorbed 93% of all greenhouse gas emissions that humans have put into the atmosphere since 1971. That's just in what, the past 40 years or so, right? No,
Oh
50
my
years.
gosh.
This is the past 50 years.
Okay.
93%, basically amounting to well over 200 zettajoules. Now, zetta is 10 to the 21. So we're talking 2 times 10 to the 23 joules of energy.
Yeah, astronomical.
Not to put too fine of a point on it, but that's a shitload.
Yeah, I know.
And that's just like uber amounts of energy. And
Yeah,
so
it's
when you look at the 7% that stayed in the atmosphere has warmed the atmosphere, has is melting Greenland, is melting Antarctica, melting the alpine glaciers, thawing out the permafrost. Right? So you have all that. As you warm up the oceans, right, warmer waters can't hold as much gas. The gas solubility decreases. So at some point, you're going to warm up the ocean so that gas solubility, maximum solubility, saturation is attained. Then after that, they cannot absorb any more gases from the atmosphere. And if you then keep continuing to warm the water, you're going to the saturation level is going to decrease, which means the water is going to outgas some of that gas back into the atmosphere. So it's not going to be able to suck down CO2 from the atmosphere, and then the ocean is going to put CO2 back into the atmosphere. This is where you get that acceleration. This is how you can get to the 5 to 7 to 9 C scenario. And
right.
here's the other
Yes.
thing. So my thinking is that, okay, we know that warming the air is causing the permafrost to thaw. And as it thaws, it releases the methane and the nitrous oxide and so on. We're warming the oceanic waters. So to me, it's perfectly logical to contend that the warming waters is helping to thaw out, melt the hydrates and the clathrates in the water, in the seabed,
The
and
whole
that
ice
is
cloth. Yeah.
and that is helping to release the methane from the seabed. And
Yeah. Go ahead.
as you keep warming up the the water, eventually that heat diffuses. That heat, the 200 zettajoules, let's be generous. Let's just say 150 zettajoules, because most of it's in the upper layers. Let's say 50 zettajoules stays absorbed in the ocean, sequestered to depth. Take that 150. That heat eventually is going to diffuse into the atmosphere. And that's going to cause further warming.
Yeah.
And
Go ahead.
this is why, because I've had people ask me, go, okay, I understand how the Arctic Ocean, because there's less ice, absorbs the heat energy, and therefore the ice freezes up later in the year. I understand that. But why is the ice melting early in the year when the angle of the sun is not sufficiently high enough? It's a perfectly legitimate question. And the answer is you have inflow through the Bering, you have inflow through the Fram Strait, and you have these warm oceanic water moving into the Arctic, and that heat is diffusing and it's melting from below.
So we have the methane issue within the ocean, and then you said the warm waters coming in. Like it's everything's shifting north because the temperatures. People, I'm sorry, the marine animals are adjusting. This is all a
Yeah,
consequence.
They're
Yeah.
moving north because, but the problem with that is like, say if you're a land animal, oh, it's a little warm. Take a dip in the pond, right? Cool down a bit, climb back out on the log. Okay.
Right.
Oh, I'm getting warm again. Take another dip. You're in the ocean. You're an aquatic organism. You can't exactly just climb out of the water.
I know. And you mentioned in your video like the pH levels, the acidification issue. I feel like there's so much going on, right? There's so many angles. Just what's been
There's a
happening.
lot of things happening all at once. And the pH, because you're adding CO2 to the water, water plus CO2 is equal carbonic acid. I mean, it's a
Wow.
weakly dissociating acid, but it still is decreasing the pH. So it still is, it's still doing something. And I did a video talking about how the lysocline is getting shallower. The lysocline is, a sharp change in water layers where above the lysocline, you can still precipitate calcium carbonate. Below that, you cannot precipitate calcium carbonate. It stays in solution. And that might be due to pressure, to temperature effects. It might be due to partial concentrations, what have you. But a lot of organisms use calcium carbonate to make their shells, make their homes.
Right.
And if the lysocline is getting shallower and shallower, they may find themselves in a water layer where they can't make calcium carbonate. They can't make their homes. And that puts them at an increased mortality risk.
Which disrupts the food cycle and extinction stuff. I mean, it gets compounding.
Yeah.
A lot of
And
stuff's going on. Yeah.
And the thing is, when we do the isotopic fractionation analyses, we can actually tell when the thermal halon circulation was flowing and when it was not flowing. We can
Wow.
tell by looking at the isotope fractions and so on. Well, the data that I'm going to present in my ocean heat content video, which if I get my damn video thingy to work,
I know. Yeah, it's too
it's
much.
just like anyway, if I if I can get that to work, but what is that I'm seeing in my analysis of the data, and people probably want to maybe dispute me, whatever, but my analysis is that I'm already seeing indications that the thermal halon flow is slowing down. So, and the thermal halon flow, which is
Wow.
vertical flow, it sequesters heat and CO2 from the surface to depth. If that slows down, then you can't sequester as much heat and CO2. If it stopped, it ain't going to sequester any CO2 and heat. And the data is showing that the great concentration of the heat in the ocean is in the upper 500 meters.
Oh, okay. Yeah, the
It's in
darkness.
now we do see it down to 15, even 2,000, 1,500, 2,000 meters, but the great bulk of it is concentrated in the upper 500 meters. Well, the photic zone, which is the level of light, is typically about 100 meters, some places, 300 meters, what have you. But 500 meters is below the photic zone. And it's very possible that, so it's telling me if I'm seeing all this heat in this upper 500 meters, that is telling me that the stratification is setting in big time. And that could eventually lead to lack of mixing of nutrients into the photic zone, where now we can then start seeing a reduction in primary productivity from phytoplankton, which then has a ripple effect throughout the whole food chain.
Could I say simply, I mean, the oceans are dying?
Yes.
Okay.
Yeah, the ocean is dying. I'll be blunt. It is. They are.
Whatever state they are in now is not going to be the state they are in 50 years or less.
If things keep as they going now, no, it'll be worse.
I
And
think,
that's why I
yeah,
did that video on the overfishing. It's just like, that's just humans that overtaken,
yeah,
with depleting the fishes that way. Now you add in the issue with the productivity leading to a food web collapse. 2 billion people thereabouts rely on protein from the ocean. What the hell they're going to do? We're going to see 2 billion people for lack of protein. and we're seeing crop failures. We're seeing whatever crops are harvested, the nutritional value is declining. We're going to see massive famine and massive starvation coming down the pipe, and that will definitely take out a few billion people.
Oh,
Definitely a couple hundred million people. So people say, well, we might have 10 billion, 13 billion by 2050, 2100. Please stop smoking that stuff because
I know
it's just
it's the numbers game.
it is that. And
Yeah, it's a lot.
it's just you see this here, and it's just like it's just a big, we're going at warp factor 7, and that brick wall is coming up very quickly.